Hi, so this is lesson 6 of Unit 1, linear scale factors and area. So we're going to be looking at linear scale factor and area this time. Before it was the linear scale factor and perimeter. So taking a look at this, it's saying complete the table to investigate the relationship between linear scale factor and area scale factor. The first one has been done. So if we look at the rectangle, over here, let's just take the pointer, and the original dimensions of the rectangle are 3 by 5. So if we're calculating the area, we multiply length and width. 3 times 5 gives us the area of 15. Okay, so what's the linear scale factor they're going to apply to the rectangle? It's going to be 2 to 1. We're just scaling up of 2. The new dimensions, therefore, instead of being 3 by 5, become 6 by 10. So what's the new area? Length times width. 6 times 10 is 60 is the new area. Now let's look at the scale factor of the areas, comparing the new area to the old area. So that's 60 divided by 14. It's a scale factor of 4 to 1, which is interesting because that's different from what we've investigated before. We looked at linear scale factor compared to perimeter, but here we're compared to area of a rectangle rather than perimeter. And it's simply because we are multiplying two numbers which themselves have been multiplied by 2. This has been multiplied by 2 to get 6, and the 5 has been multiplied by 2 to get 10. So it's like going from 3 and 5 to 3 times 5 times 2 times 2 to get the new area. So really, in a sense, we're scaling up the area, even though we only scale the dimensions by a factor of 2, we scale the area by a factor of 4. So we can fill this in for the other 3 examples. I'll do just one more. And so it's 9 by 6. So what is the original area? 6 nines are 45. And we're going to apply a 1/3 or 1 to 3 ratio. So we're scaling down. So basically our dimensions get divided by 3. 9 divided by 3 is 3. And 6 divided by 3 is 2. So there's our new dimensions. So what is a new area? Simply going to be 2 times 3, which is 6. Let's look at the ratio, scale factor of the new area, 6, compared to the old area, 45. Now if we look at that, we reduce this, 6 into 6 goes 1, and 6 into 45 goes 9. So we're really getting 1/9. Even though we had a linear scale factor of 1/3, we're getting a 1/9 scale factor with regards to the area. Now we can do the same for the other 2 examples. So quickly, original area 4 times 8, original area is 32. We're applying a scale factor of 3 to 2. So we're multiplying by 3 over 2. So the dimensions of the area for the new rectangle are going to be 4 times 3 over 2, 12 over 2, so that's 6. And then 8 times 3 over 2, so 24 divided by 2 is 12. So the new area is 6 by 12, so 6 times 12, 72. We look at the new ratio, new scale factor of the area, 72 divided by 32. You can see what's that going to be. Well, basically, I believe it's 6 over, well, what's that going to be? You have to get the calculator out and reduce. So 4 goes into that. That's going to be 9 over 4. Scale factor of 9 over 4. 8 goes into that 9 times, and 8 goes into this 4 times. Won't do the last one here, but it's the same idea. So moving right along, we'll go down to part B here, and it's asking compare the linear scale factors to the area scale factors, and you can see that the area scale factor is equal to linear scale factor times 2. So basically we took this and multiplied by 2, took this scale factor, multiplied it by, actually no, we're squaring it, sorry, forgive me, I believe we're squaring, yeah, we're squaring. So the area scale factor is actually the linear scale factor squared. 2 squared is 4, this squared becomes 1/9, remember, the squared becomes 9/4, and so on. So if we were to do this one, this would be the other way, 4/9, the square of this scale factor. Okay, so this is what we need to note, that the area scale factor is actually the linear scale factor but squared. Moving on to plus example 1. Maggie has scanned an 8x10 photograph to her computer. Maggie would like to increase the size area by 44%. That's the area by 44%. Determine the area scale factor and the linear scale factor. Okay, so let's think about that for a sec. So, we've been given the fact that she'd like to increase the area by 44%. So that means the area now becomes 144%. The original was 100% plus the 44, so 144. So that's the new percentage, or 144 divided by the original of 100. So new scale factor. That's the area scale factor. Now we want the linear scale factor as well. So notice that the linear scale factor is the square of the area scale factor from above. So we have to basically square root the area scale factor to get the linear scale factor. So here we have 144 over 100 equals 12 over 10, or 1.2 over 1. Explain why these scale factors are different. Well, it's the same as the exercise we did above. And we are basically, when we look at the dimensions of a photograph or an object, then when we multiply, when we increase the size of one dimension and the other, and then we multiply them together to get, say, the area, we are multiplying by the scale factor once here and once here, so we're multiplying by the square of the original linear scale factor. Determine the dimensions of the enlarged photograph. Well, if we have, we're scaling up the linear factors by 1.2, then 8 gets multiplied by 1.2 and 10 gets multiplied by 1.2. So 8 times 1.2 equals, I have it in the calculator here, 8 times 1.2 gives 9.6, and then if we take 10 and multiply it by 1.2, we get 12. So the new dimensions are 9.6 by 12. And let's just make sure, if we do get an area that's increased by 44%, so it should now be 144%. Let's check the area. Well, let's multiply these two together, and we get 115.2 is a new area. Okay, let's just check what's going on here. So we want to check the area scale factor We can take this new area and divide it by the old area. Now the old area would have been 8 times 10, or 80. Let's look at question D here. The enlarged photograph will be printed at a digital print shop on a color printer. Assuming the white areas of the photograph will also use ink, calculate the area the printer must cover by the following two methods. Using the dimensions of the enlargement. Well, the dimensions of the enlargement, you can see as above, we just calculated, it's 115.2. Using the original area and the scale and the area scale factor value. Okay, the original area was 80, and we're using a scale factor of 144%. So we multiply that by 144 divided by 100. So let's just look at what that turns into. 80 times 144 and divided by 100, and we get the same answer. So 115.2. We can just check this ratio. 115.2, if we divide it by 80, do we get the linear scale factor of 1.2? And let's just check. Divided by 80. Sorry, no, we do get the. Sorry, these are areas. So yes, we get 1.44 or 144%, as we would expect. Okay, moving on to the next example. Okay, that's asking us one last question here. E. Maggie must also produce a print whose area will be reduced by 25%. Determine the dimensions of the print to the nearest 100th of an inch. So that's how I think about that. Okay, so I've drawn out here that the new percentage is going to be reduced by 25%. So originally it was 100%, so it's gone down by 25 to 75%. Here's the new percentage, here's the old percentage, so 75 over 100, that's the area scale factor, the new scale factor for the area. And as before, the linear scale factor is going to be the square root of the area scale factor, so square root of 75 over 100, which turns out to be a decimal 0.866. So if we want the new dimensions for the linear dimensions of the print, which was 8 by 10, 8 gets multiplied by 0.866, and 10 also gets multiplied by 0.866. And the new dimensions are 6.93 in 2 decimal places and 8.66. Example 2. Marco, owner of Math11 Incorporation, has produced a map of Canada of his employees. The area of the province of Alberta is approximately 661,850 square kilometers. On Marco's map, the area of Alberta is represented as 264.74 square centimeters. The scale of the map, the linear scale factor that is, can be written in the form 1 to a number, and we're calling that number x. Calculate the value of x to the nearest whole number. So again, the one is to calculate the linear scale factor based on this, the area scale factor that's implied here. So we're going to have to calculate the area square factor with these numbers right here, and then square root it to get the linear scale factor and find x. Okay, so these units are different. We're going to have to make them the same to figure out what's going on. Okay, let's have a think about that. Okay, so looking at these two figures, if you consider what a square kilometer actually is, a square kilometer is 1 kilometer by 1 kilometer. Well, what is that in centimeters? Because we want to make these the same units. Square kilometer is 1 by 1 kilometer, but in centimeters, let's convert. There's 100 centimeters in a meter, and 1,000 meters in a kilometer. So if we multiply 100 times 1,000, we can find that there's 100,000 centimeters in 1 kilometer, or that's 10 to the 5 centimeters. So a kilometer is 10 to the 5 by 10 to the 5 centimeters. Giving the area of that in square centimeters would just be 10 to the 5 times 10 to the 5, giving 10 to the 10 square centimeters is equivalent to 1 square kilometer. So let's use the same units now to get the scale factor here. A ratio of 264.74 square centimeters to 661,850 multiplied by 10 to the 10 to scale up into square centimeters. So we've changed this area in square kilometers to the area in square centimeters here. We're reducing this to 1 divided by, I've divided this by itself, so divided this by the same number by 264.74. So this ratio works out actually to be 1 over 2,500 times 10 to the 10, or another way of writing that, and using these two digits, moving the decimal point over twice, that would increase this to a 12. So it's 25 times 10 to the 12. So that's the area scale factor. 1 centimeter in map is equivalent to 25 times 10 to the 12 centimeters on land. Now the linear scale factor is always the square root of the area square factor. So square rooting this, square root of 25 is 5, square root of 10 to the 12 is 10 to the 6. So this is the linear scale factor. So x here, what they asked for here, it's 1 to x, or 1 to 5 times 10 to the 6 is the actual answer that we're looking for here. Part B, on the same map, the area of the province of British Columbia is represented by 376.839 square centimeters, determining the actual area. Well, we can use this area scale factor. 1 on the map is equal to 25 times 10 to the 12 on land. So, if this is what's on the map, we just have to multiply it by 25 point 10 to the 12. 25 times 10 to the 12. So if we do that, we will get 376.839 times 25 times 10 to the 12, and that will give us a square area, centimeter square, for doing those units. So with my calculator, 25 times 376.839, so we are getting an answer of 942, basically 21 if I round up a little bit, times 10 to the 12 square centimeters. But remember, we want to convert this back into reasonable units for land, so square kilometers. Okay, so notice, as I mentioned before, that 10 to the 10 square centimeters is equivalent to 1 square kilometer. So to change, we can take this and multiply by the ratio of that. 1 kilometer squared is equivalent to 10 to the 10 square centimeters. So these centimeters cancel, and basically we get an answer of 9421 times 10 to the 2. Or, if you want to just look at that, we're going to add a couple of zeros. 942,100 kilometers squared for the area of BC. Okay, so if you would wouldn't mind doing the all the questions to this assignment number 6, when you get to class. Maybe try question 1 right now.